Hello everyone, welcome to this video lecture on design methods in steel structures. This session is a part of Unit 1 of Design of Steel Structures, focusing on the fundamental design philosophies used in civil engineering practices. Before we dive deeper, let's quickly recall what we learned so far. Steel structures are widely used due to their strength, ductility and reliability, but designing them safely and economically requires proper design methods. The topics for discussion for today are working stress method, ultimate load method. In this video, we will focus on two major design methods, that is working stress method and ultimate load method. We will understand their assumptions, advantages and limitations. So why steel in construction? Steel is preferred in construction because of its high strength to weight ratio, ease of fabrication, and ability to withstand dynamic loads like wind and earthquake loads. It also allows faster construction and better quality control compared to conventional materials. Design philosophy. A design philosophy is a set of assumptions and procedures used to ensure safety, serviceability, economy, and functionality of a structure. There are three main design philosophies: working stress method, ultimate load method, and limit state method. In this session, we mainly focus on the first two. Working stress method. The working stress method is based on the assumption that materials behave elastically under working loads. This means stress is directly proportional to strain and the structure remains within the elastic range. To ensure safety, we introduce a factor of safety which reduces the allowable stress. In simple, we design the structure so that the actual stress is always less than the allowable stress. We move to the concept of working stress method. In this method, we compare the actual load acting on the structure with the allowable load. If the structure is load on the structure is less than the allowable load, the design is considered to be safe. However, this method satisfies only serviceability, meaning it ensures no excessive deflection or cracking, but ultimate failure and safety. The limitations of working stress method are: it assumes purely elastic behavior, which is not always true. It cannot handle multiple loads acting together effectively. It ignores secondary effects like creep, shrinkage, and stress concentration. Because of these reasons, it may lead to unsafe or non-conservative design in some cases. Another major drawback is that it results in oversized section due to high factors of safety, making the design uneconomical. However, it is still used in special structures like water tanks and chimneys. Typical factor of safety values are 3 for concrete and 1.78 for steel. Now let's move to the ultimate load method. This method considers the non-linear behavior of materials and designs structures based on the ultimate strength. Here safety is ensured by applying a load factor to the service loads. So load factor is defined as the ratio between the ultimate load to the service load. To summarize, working stress method is simple but conservative and less accurate. Ultimate load method considers real behavior but focuses mainly on strength. Modern design generally uses the limit state method, which combines the advantages of both. These concepts are based on standard structural engineering resources and references provided in the above slide. Thank you for watching this video. If you found this video helpful, don't forget to like, share and subscribe for more civil engineering content. See you in the next lecture. Have a good day.